I'm thrilled to be here. I have planned this session as a quick call to action to tackle some challenges of opportunities ahead of us. The narrative will be pretty simple and straightforward with a quick intro, contextualization, then jumping into the discussion into what are the applications for the next term quantum computing. As an industrial engineer, let me share my screen. Let me share my screen with the apps over there. Window. Sure. I'm an industrial engineer, and let me put it over. So you get kind of an eclectic training. You get to be like a jack of all trades, and in the context of being aware of the process and components in different industries. Being eclectic in nature, you get to deep dive in some topics along the way. In my case, it's been technology. The good thing from this is, first, you get to meet a lot of extremely brilliant and clever people along the way. Second, you get used to figure out how to match those innovations with current business needs and corporations' challenges, and you get better advising and supporting organizations toward adapting for the twists and the bumps ahead on the road. Third, and I guess one of the most important, is that there is no perfect solution from the technological standpoint. And I'm guessing that technology is an always working process thing. It's a continuous improvement, and that's an important thing in terms of how do we evaluate the quantum technologies currently today. So businesses are so dynamic, it means good enough. It's an approach acceptable in terms of business. When you get to the quantum world, there's a lot of different perspectives in terms of how realistic it's perceived. Pretty much varies a lot depending on who are you talking to. In my personal opinion, the terms of futuristic may be somewhat misleading in terms of there's a lot of already happening today in the quantum computing market and ecosystems, and we'll take a glimpse of that soon. I wanted to start by contextualizing where we are now, and for that, just a quick check on historic development and milestones. We as humans are quite linear in terms of the way we perceive it, where at a certain point that was fine for the scale of human. We did well, moving from hunting to agriculture and so on. This implied considerable changes in the way our society develops and interacted, and pretty much how do we interact in the society and how we made business, by the way. We thrive to survive, we grow, and at a certain point, we try to extend our natural capacities, which is pretty much the definition of technology, the extensions of any human capacity. And things move kind of somewhat okay and stay linear until the Industrial Revolution. And from there, things move quite on a different scale and dimensions. At a point, we probably didn't perceive well the magnitude of our impacts and our challenges. In my personal opinion, it's just like at a certain point, we humanity overcome the things we can tackle, the things we do on our own. Fast forward, and the rate of growth, population, technological advancement, even economically, surpassed by far the capabilities of us humans to tackle those problems in growing complexity. In the midst of what we call the fourth industrial revolution, the world we live faces tremendous complex challenges due to our own scales, hyper-connected, climate change, growing population, So those means also opportunities for us. And that also means how we can create business actionables from that perspective. New challenges require new solutions, and here's where quantum mechanics poses such a completely new approach, and hence the disruptive nature for quantum computing. Using different quantum computing has proved to be a tool to tackle that. Otherwise, like it will take forever to face problems in complexity. Let's say, for instance, transit within this super crowded city. I won't be going further about the qubits and the different technologies we currently in use or in development. We will focus the next few minutes into the potential applications from those into the real business case. Even though the timeline may be revisited, the important thing for us is that currently, today, there are companies and startups already starting to make money from this. Let's mention a few possible scenarios where quantum technologies and quantum computing poses great potential. In order to tackle where business is, let's get some help from Porter's value chain reference model. This has been around for probably 50 years or something, but it's a great tool, in terms to understand what are the key components in any businesses. And even though it changed depending on the kind of industry, especially in the services industry, you can find different models. It's a pretty good guide in order to move forward and understand where we can devise some value and some actionables from specific industries. In this case, we're going to be talking about the ones we're putting over there. So let's go, for instance, with the first one. The mining industry may become such an important actor. First, there are many processes that are directly related to the quantum nature of chemical and mechanical process. For instance, determining the right location and proper extraction processes, plus all the complexity related to a heavy supply chain, energy provision and consumption, drilling, blasting, processing, managing a fleet of monumental automated trucks. Most of the time, these huge trucks over here are basically automated vehicles today. The scale of the mining industry makes them a perfect candidate to become a huge beneficiary from quantum computing solutions. Let's say, for instance, manufacturing also. In the manufacturing industry, it's another great candidate for quantum computing scales. You can face issues like defining plant infrastructure, facilities in terms of energy consumption, power again, supplies, services. Those aspects related to how you optimize the way you organize things inside a warehouse or the way you arrange a certain assembly line. Let's say, for instance, today, there are actual solutions that are running and being tested in, for instance, the vehicle manufacturing industry. We got the samples going now with BMM and Volkswagen. There are already running initiatives researching on existing new algorithms capable for providing improvements on the development of new materials and fabrication process, even at the scales of integration into small city solutions, or the enhancements in data analysis towards enabling an Internet of Vehicles. In this case, you can see like we come back to the scale issue again for challenges related, for instance, to transit, pollution, congestion, transportation time are just a few samples of how things cannot be tackled otherwise. And this is where, again, an area where optimization that can be derived from new quantum algorithms can provide a great benefit to this industry. Let's say natural resources, for instance, and in this specific case, the pulp and paper industry. Pulp and paper industries also, it's a reasonable candidate in terms of the scale and in terms of the challenges they face. Issues like defining the location for seeding and growing the raw material, basically forest and woods, and finding what is the right time, the right combination, and getting into the right equation to get a better production line. And going back into production, you get processes like pulping, refining, fiber production, bleaching over there, press, drying, coating, you name it. Into that, you got shipping, distribution, the output distribution. So there's a lot of room in terms of optimization for, let's say, the planting and growing, the seeding, the whole process of growing basically new woods and renewing the material. We'll mention the logistics and the fleet optimization again. You can define new route optimization in order to make these processes better. Let's say, for instance, there are some researchers already with some few vendors where they are already working toward getting improvements in the warehouse management, and thus have showed improvements in terms of process, time, and travels that can be trackled to something around like 10 to 50% improvement. So that is a huge impact in terms of the whole value chain again. Let's go to a different business, the retail industry, for instance. Even though it may not be that such traditional industry value chain, there's a lot of things that can be derived from here in terms of complexity. And the retail business is quite an interesting one because first, like many others, they've seen quite a rush towards digital transformation expedited due to pandemics. The transition from physical to online is way beyond the deployments of e-commerce. There's a reason. The reason is that there is a lot of physical work required towards inventory management, supply chain, provisioning, purchasing, delivery, fleet management, quality assurance, plus increasing amounts of data from customer analytics to better understand customers' behavior, and design, improve customer loyalty strategies. The famous travel salesman problem, the TSP, is a great example for this. For applications of computers in different links in the value chain. This is such a complex problem in terms of it grows in components for the solution. So it's definitely something that is already happening today. Also applies the same for the capacitated vehicles routing problem, which is pretty much, again, how we manage the transit within a warehouse, how we program and schedule the flow and the organization. Also for store locations, so distribution points with associated optimization, transportation, logistic expenses, plus reduced pollution footprint, which is also a good thing today. Thinking about, for instance, how we contribute into the climate change. Last but not least, let's talk a little bit about finance. A few weeks ago, I posted about the importance of a balanced economy and thus the direct impact to people's everyday lives from optimization in economy and finance. Using as a basis research from local academics, there is a great example from quantum extension from the Black-Scholes model, which is widely used in price option contracts, where scientists propose a quantum mechanical approach to tackle a complex market phenomena. And here we come back to what I mentioned in the beginning. This is a completely new way to trying to match how the multidimensional quantum nature can be matched to extremely complex scenarios like the market, for instance, the market phenomena. It's a very complex scenario, and it's kind of fascinating because economy, it's pretty much like you define a variable and suppose that everything is context. So it's quite erratic in that way. So in this case, scientists has proposed to match the free behavior of a particle from the states of equilibrium that may be the same as the results of some market imperfections, such as transaction cost, asymmetric information issues, short-term volatility, extreme discontinuities, or serial car relations. And that defines pretty much creating an algorithm that can match in terms of how they behave, how the market is going to behave, and defining optimizations in terms of the price of contracts or options. And you can also go into portfolio analysis and improvement, training strategies, reducing fraud, insurance optimization. There are, just to name a few, optimal trajectory detection for investments, trend anomaly for trading, just to name a few. This is happening right now, today, not in the next 10 years, not in the next 5 years. It's happening today, and actually you can see from some of the pictures I posted here, these are just some samples from business cases that are already being running with some players in the industry. This is happening with real quantum hardware using custom design quantum algorithms offered in a cloud. And if all of this is not enough, add cryptocurrencies to the game. It is already acknowledged risk that current encryption systems can be defeated using quantum computing. Computation says Shor's algorithm. And in this very moment, there are several teams working on post-quantum computing. Just to put it in perspective, an important part of the cloud security is based on identity access management and the provisioning of a secret, which is basically a cryptographic key. You can make the conclusions on your own. Nowadays, there are devices, including new mobile phones models, providing a new security mechanism based in quantum random number generator, QRNG, using the properties of the quantum physics to provide a new layer of security. So, with that being said, I'm pretty much returning to the conclusions, which are basically self-explanatory. Quantum technologies is not an if question, but a when question. And again, I would insist on this. In my personal perspective, futuristic, it's not helping the quantum market, because this thing is happening now, today. You can go and research on your own on the website, and see several business cases that are already happening. So this is a call to action for us in terms of not being left behind. There are a lot of traction from big countries and big economies in the world. Most of them, they're pretty much pushed by national initiatives declared or in progress, pushing toward the development of quantum ecosystem, and they are explicitly stated taking the lead into this new economy, into this new challenge, which is actually changing, and will change real soon our current state of art. There's something important here, is just like the skills, expertise go beyond physics. Business, most of the time when you talk to business, they're not scientists. So we need to take the language back to businesses, understand the business cases, understand the pain chain, where the pains are, where we can provide value, how that is engaged into the processes, and at the end of the day, how we make money in terms of business, or how we put money aside, how we create value from this value chain. Let's take, for instance, something that was mentioned previously, the climate change. It's not about money, but if we can contribute and provide some additional improvements in the many different processes that we have in terms of energy consumption, optimizations in city, management of large crowds of people, and how we can make them a better life, that's going to be a huge impact in our society. And last but not least, being aware that growing ecosystems are growing everywhere, and pretty much we're here to nurture awareness. And the quantum market is expected to reach billions of dollars, something around like 50 billions by 2030. That's the forecast. So the sooner we jump in, the better. At this point, seeing this from a business perspective, it ain't going to be pretty much a strategic decision when this become already the mainstream. And I remember jumping into, let's say, for instance, cloud computing, something around like 18 years ago. It wasn't named cloud by there, but there was a lot of technologies going in. And being a young guy, I just decided to take those projects in technology that pretty much no one else was willing to tackle. Fast forward then, and you get cloud, which is the mainstream. It's pretty mainstream. It's pretty much everywhere, and it's not that just technology, but it's just a model of doing things in a different way. In this case, doing and offering computing capacity as a service, as a pay as you use, and that enable new businesses. Let's say, for instance, when you wanted to research and do. Let's say, for instance, in chemistry or natural sciences, you need a lot of computing power in order to do simulations and make analysis. And those computing powers were not available to the average guy over there. Now you can go with a credit card and sign in any of the main cloud providers and get access to quantum simulators or eventually a real quantum computers and start trying and learning on your own. Well, that's all what I had to do for you today. Pretty much appreciate your time and thank you so much. If you have any questions or something else you'd like to discuss, please let me know.
Thanks very much, Raùl, for that talk. Definitely, most businesses are risk averse, and that poses a challenge when you bring such concepts to them. I think they're looking for a more than a proof of concept for that idea for them to work. And like you highlighted, having that suitable business case for them, how can, or what I term as a quantum business case for them for various industries that could actually help, and having leaders like you can actually drive around industries to say, how can we implement this? How is it beneficial for you? A question we have also is from the African chapter president, Raùl, asks, how does the ecosystem in Chile look like, and how is the conversation going there?
Okay, thank you. That's kind of a interesting question. Honestly, I think we got a geography problem eventually, since we are far from everything, and eventually we probably got late to many of the different revolutions. Once I've heard Chile was a poor country in terms of the current energy sources. And we are a rich country in terms of the new energy sources, let's say solar energy, lithium, and many other things that we already have. I'm guessing like we're still tied to the natural resources economy, pretty much. And it's like an interesting time in order to create and increase the awareness, especially from the political and governmental realm, in order to provide additional support. I've seen we got a lot of talent around, especially in academia and the industry. I think shouldn't be a problem for us. I'm just thinking out loud at this point. Shouldn't be a problem for us in terms of getting the workforce. We got good engineers, good computer scientists. There's a lot of research here, and we got a healthy, large industry. The scale, again, is important because at the end, in order to create these proof of concepts, you need to figure out what is the return, basically. What do you need to invest in terms of people, in terms of effort, in terms of timing, and what is the return you're going to be getting. So we need to make it real for businesses. And I'm guessing that's one of the main challenges, because every time you talk to academia, they tend to talk in a slightly larger time frame, which is okay for the academia. But for businesses, they tend to be a little bit shorter. So we need to find a balance for that. So that being said, at this point, we just pretty much everything settled in order to move forward. So at this point, we should be moving toward getting the right actions, especially from the governmental level, in order to help us and move the ecosystem. And at the same time, the best thing at this point is just like getting collaboration from the whole Latin America. Basically, we get our great ecosystem, and there's a lot of contributions from people, not just in Chile, but from everywhere in the continent. So definitely looks very promising.
Thanks very much, Raùl. I don't think we have other questions. For now, we can just quickly take a group fee with everyone who's in here for the session, and then we can proceed to the next session. So in your screen, you should see a group fee there, and then put up to big smile, and then I will start taking it. Okay. So in the count of 3, I'll do it. 1, 2, and 3. Here we go.
So at this point, it is just the two of us, right?
Yeah, so there's still more and more people are still taking in the best photo or the best pic that they have.
Okay. I never used it before.
Yeah, it's a cool picture. It's a nice picture, and I guess this will actually be sent to the email in which you register the event, so you can share it with everyone publicly.
That's really cool.
Okay, I hope we are all done, and then we can just go to the panel discussion session. See you there, everyone.
Great. Well, so that being said, I'm guessing we are done for now. Maybe we can have a session later to talk a little bit and figure out what your feedback.
Cool. I'll appreciate that, Raùl. Thanks very much.
Welcome very much. Take care. Bye-bye.
Bye.